Okay. Morning, everybody. Welcome to day 3 of FOSS4G North America. This is the FOSS4G for Government track. We have 3 talks, 30 minutes each. The first speaker is Jessica Moehl from Oak Ridge National Laboratory. She'll be presenting utilizing open source technology to enable science at Oak Ridge National Laboratory.
Thank you, Joel. I think we've got an exciting stack of 3 talks here today, so get comfortable. I think we're going to do good. So, first, Oak Ridge National Laboratory. I don't know if you've heard of it. We are in East Tennessee, and we are about 6,500 staff right now, solving all kinds of different problems, and lots of different science areas. So you've got supercomputers that make the building really cold, and we've got 3D manufacturing advancements in the bottom middle, and then you can see interesting guests that we've had, a couple presidents there at once, looking at that 3D printed car. So Oak Ridge National Laboratory has a very broad science mission, lots of science areas, but I'm going to focus on the stuff in the bottom corner, the geospatial science that we've been doing for a couple decades now. So the picture that you see is one of our large population models that has been what I've been working on in my career. So in geospatial, we have a division of about 100 people. We have research focus areas of high performance geocomputation, human dynamics modeling, critical infrastructure resiliency, that's kind of where Aaron's talk is going to be at 11:30. Remote sensing, so we've got some of the core science within all of the applied space. And then obviously a very emerging thing is that GeoAI mapping that has a lot of traction right now. So we do this for situational awareness, critical decision support, crisis management, lots of currency to a lot of the work that we do. And these are some pretty pictures of data sets that we use, data sets that we produce. And one of the themes that we've kind of seen, some of our keynotes, some of the other talks I've been in, is how do we, in open source, make data available to scientists and then make their model outputs available back out. And those are the types of things that we do in my group within that division. So I want to first start out with a little bit of a reflection, which goes well with the second keynote that we had this morning. He talked about Google Maps and how it's rather unimpressive to us to have that on our phones. But Google Maps started in 2005. So I'm under 40 and still remember very much when that didn't exist. My parents were like, what are you going to do with that degree? Are you going to be a coach? Are you going to teach high school? So geospatial has really changed a lot. My mom today went on a field trip with my daughter, and she knew where to go by herself because she could just punch it in on her phone and follow that. So that spatial awareness is ubiquitous now. Everybody's parents. And that's really important to consider as we move through time in geospatial, I think. So another thing is this map, this chart on the bottom. I use tag info for that, which is a really cool site if you want to explore what open source or what OSM has to offer. But this is the building tag, and 600 million features in OpenStreetMap tagged with building. And that doesn't include really the Microsoft and Google's billions of records that they've dumped into the open. But in 2010, there were almost no buildings there. So within that time span that I've been in Oak Ridge, so those 15 years or so, the amount of information that's available to bring to bear in the science we're trying to do has changed dramatically. And it changes the questions we ask. It changes how we can ask those questions. And I think a lot of the tools have changed as well. And that's kind of the exciting stuff. And one more slide just to hammer that home. Imagery. Brian did a great job saying you can get an image for $175 of Antwerp on your phone in the next 5 minutes or something. But when we're trying to do large-scale geospatial analysis, and in 2007 you wanted to say, let's map the Horn of Africa, there's not a lot of imagery available for that. And this is the half-meter Maxar stuff that we used in this sample. But you can see over time, starting in around 2002, you could get a few images, but you couldn't get a whole lot. So, and even now in like 2021, 2022, in that 2-year time frame, you've got most coverage and you've got options at this highest resolution imagery. But then you've got people like Planet Labs who are promising daily landmass coverage of the world. It's a little bit lower resolution though. But still, I think that the amount of things you can ask are incredible. And the geospatial tools and the users of that geospatial tool set has changed dramatically. I would say, in my opinion, what we've done at Oak Ridge has been a mirror of the rest of geospatial. Sometimes we do things a little differently because we are asking different questions in a different way. That's kind of the space of the national laboratory, kind of, where we kind of sit between federal and industry, so we can kind of fill a unique role in the things that we do. But there were about 25 people there when I got there around 2009. Everybody had a desktop, 2 monitors, we were really cool. You had ArcMap on one screen, or ArcView, and then you had another screen, and a summer intern made a cool thing where Google Earth would move while you moved your window, because you didn't have imagery in the background. That wasn't a thing. The base maps were Landsat, but still, that was cool. But our present day is so much different. We're on laptops. I've been working in my hotel room, logging into all of our compute on-prem. We've got, we're doing things in the cloud. So a lot of our challenges end up being, how do we share those things? How do we get people to use different tools? Something that we notice is that QGIS wasn't really going to cut it in 2009, but in a lot of cases, QGIS is doing better than what we can do to display and symbolize it, and a lot of that stuff. So it's been really exciting to see how open source geospatial has come, and when we hit limitations with the proprietary stuff, we can find solutions in the open source. Or if there's a problem in the code base, you don't have to wait for the next version to come out. Maybe they'll fix it in 9.8, Esri. No, you can fix that yourself. And that's been one of the big things in my career. So I'm going to switch to some examples of kind of what I've been talking about, how we kind of reach the limits and how open source has enabled us to do better. So one of the things that we are most well known for is our Landscan population modeling. And this slide is about Landscan USA. The global product we have is kilometer resolution in the US. Because we have better data and information, we can model at a higher resolution in both space and time. So it's about 100 meters, and it is a daytime and a nighttime thing. So I've been working on this problem, kind of trying to make this model work with the data that's available since 2009. And 90 meters felt really, wow, this is really high resolution. And now we kind of ended up where we were processing all of that stuff into rasters. So before, we had a time period from 2005 to 2012 as kind of epoch 1 of Landscan USA is how I think of it. And the model framework was really based on where aren't people, not where are people. And you kind of pushed people away from things, or maybe pulled them towards roads and things like that in a very traditional raster-based analysis. And then we had a break from 2012 to 2017, and we were able to start modeling with a lot of the feature extraction from imagery work that we had been doing for other projects was really promising. So we said, let's take NAPE imagery and extract the buildings for the whole US. So in 2016, 2017, we had the whole US extracted in NAPE. And then we took that beautiful little polygon and rasterized it, because we were raster processing. And you look at that and you go, man, that sucks. I had a really nice polygon, it describes an entity, and now I've got pixels that describe building area. And rasters are nice when, they're very fast. That's the pedagogy of geospatial says, raster is faster, vector is corrector. But at a certain cell size, raster gets slow. So you can see here, I rasterized these parcels on a single value, and it was really upsetting. Okay, that's cool. I can't tie back to any of that information though. It's just a raster with a land use value. So this was, really hard on my science brain. I wanted to ask more complicated questions. And that was, I want to model at the building level. I need to go to vector. And we had been storing all of our data in PostGIS, in the PostGIS environment for reading in and out in that Esri environment, which, has its own challenges. But we ended up going, you know what? Paul Ramsey's been doing a lot of really good work on PostGIS. It's getting a whole lot better. I think we can develop some queries where we can actually do this geospatial analysis in our open source, move it to Linux servers and really crunch through this stuff. So the big things that moving into that open source into PostGIS allowed us to do was move the computation up front. It's going to be a lot of work to do all of that data joining and fusion, but you don't lose any information. You can always link back to the source data sets. And in raster space, you have to make decisions, and every time you want to change something, you have to re-rasterize that on a different value. Or, I want to think about res non-res as res multifamily single family. Well, now I've got to re-rasterize that. I've got to make sure I do that right. So, the science questions you can ask are clouded by what is our computational, what's our time frame for that, and all of that goes away in this framework. And kind of the things that we do in this really start to converge over time. One of the things that we did from that NAPE imagery was, say to FEMA, hey, we can give you guys a building map of the US for your analysis. And that's something that they sponsored us to do for a 5-year period. And we just finished a phase 2 where we put that open source data set from FEMA. We got attribution of occupancy or land use on every one of those structures. And we did that computation and storage in PostGIS. This diagram in the middle is kind of the logic flow. How do we want to make a decision about what type of building that is? And PostGIS makes that just so easy. So these are just some of the data sources. Highfield is an open federal government data set that has tons of different layers, and we can use census data for res non-res, and then parcel data from partnering with the federal government. And that lets us build tool chains like this, where you have a data stack, and you've got a column for every data source, a row for every building, and you can query, just say, how many buildings are a nursing home and a hospital, or are the schools in Highfield and the parcel data set. So you can learn a whole lot about the relationships of different data sets and how those classifications happen in a really cool way. And that can feed into more science. You can iterate through all the scenarios. And that's been a really beautiful thing for us. So this is kind of an implemented hierarchy after we did that. Okay, we like this answer best. Okay, now take this note. Which is very similar to a lot of the techniques other people are using for this. As another example, we have some machine learning and AI workflows that are concurrent streams of R&D, and you got different people doing it, maybe people with slightly different teams. Oh, they're using the building data too. Hey, did you tag that? How did you do it? So we realized we were doing a lot of the same sorts of things in different projects, kind of siloing that, and we started talking about some of the work that other people are doing. Hey, how about we take those things that are buried in a project that were built with certain assumptions, rethink that with more modern technology, move that thing that you're doing into a more generalized form so that we can do it once and then share it. And so you can see in this diagram of kind of a workflow where we had the same code for a slightly different thing, and we were able to say, hey, let's take that. Our goal isn't to produce a new data set, produce a new algorithm, it's to move that code and focus on moving that code into a more usable format for our peers and coworkers and other scientists. So for that particular little module buried in different code bases, it was in a Python as a read on a single workstation environment. That was its constraint. It's built on the bones of the machine. Anything that you do on that machine might kill that workflow. So over time we got to where get rid of the Esri. Now we can throw it into Docker. And now we can throw that onto a Linux machine, on-prem, on cloud, wherever we want, and do all those calculations that we're doing over billions of features as fast as we want. And once we started doing that and talking about what we were doing there, we had a data set that everybody was wanting to, this became a hammer, and everybody's problem was a nail that we could use this for, and that's been growing and growing within our organization. So that leads to, okay, now you've created code that runs and is trivial-ish to run and process. Okay, now the conversation moves to, hey, can I run that code? No, let's do one better. Let's just pre-process that however we need to do it for that application, make that visible to everybody else so that maybe they haven't thought about those data sets in the same way. And that's where we get to this kind of open database concept that we have right now. We have, if we're going to build a production workflow, PostGIS is working really well for us in a lot of other environments. So let's start there, and then we can build, we can experiment on how we want to make that data accessible and communicated among our teams. So we've kind of consolidated our data acquisition across all the projects into this. Let's just store it on a big beacon machine, and everybody can come get it where they want. Somebody that knows about that data a whole lot can write a wiki page, and then somebody else that wants to use that data can read that wiki page, and then the first time they talk to that data expert is going to be a conversation about a much more intelligent conversation. So we're really trying to move those conversations using all of these open tools so that our researchers can focus on that. So kind of thematically, and I think Overture Maps uses a very similar category and structure for a lot of their data. So, we've got footprint data, height data, land use. These are the different sources for that. This is why we like that one versus this one. So we've really focused on, those things being outcomes of all of our data work. And then we're going to store them in the same place. Oh, another thing we might do is my workflow, I need these things calculated on every building feature. Okay, why don't we move that calculation into the ETL step? Okay, now everybody else can use those columns too. Oh, and we've got the setup to tell other people what those columns are. So we've seen a lot of really good promise from kind of abstracting the thing that you think is unique to your problem to be able to use it in other areas. So we've seen a lot of value add from consolidating that. So just the key takeaways for us is that we're spending a lot less time talking about, what exists, where does it sit, how do I get it, and a lot more time talking about how do we use that? How is it going to perform? What have we seen? And, everybody's playing with it and seeing, okay, this is really interesting. And open source has evolved in a way that has really enabled us to do that. You can have a lot more creative thought and flexibility to do that within the open source ecosystem that just was not going to be a path forward for us in the closed systems. And I'll end on this. These are USA structures and the landscape population models that we have are all open data that can be accessed. I think USA Structures is on Esri's Living Atlas too, if you want to use that as well. We have a technical report that talks more detail about all those decisions that I talked about. At FOSS4G 2021, I talked about the modeling framework a little bit more in depth, and then we have another data layer that came out of COVID, where we were saying, the fundamental thoughts about where work happens and things like that, where activities happen, had changed a lot. So we have a paper about that as well, and an open data set with that. So I think we are good on time. If anybody has any questions or comments, just questions, no comments now.